Hello and welcome to another tutorial on operators in Java. We're looking at the conditional operators, and we know that these are for logical decisions, and we can use them in the parameters of an if statement. We know that in Java you write down if and then a pair of round brackets or a pair of parentheses, and inside you put a condition. And you can use logical AND or logical OR. Note that these are not the bitwise AND and bitwise OR. These are logical AND and logical OR. So you use two ampersands or two pipe characters for logical AND and logical OR. And if you're not familiar with the truth table and how the truth value or the Boolean value of the AND expressions is evaluated, for the AND the result is true only if the left hand side and the right hand side are true. For the OR, the result is false only if the left hand side and the right hand side is false. Otherwise it's always true. So the logical AND and OR operators perform conditional AND and conditional OR operations on two Boolean expressions, and these are again binary operators. And we said that in Java the guarantee is that the left hand side will be evaluated first, and after that the right hand side will be evaluated, and then the return value of the two sides is passed to the operand, the binary operators, so that the result can be evaluated. These operators exhibit short-circuiting behavior. Oh, this is a nice trick, and that could lead to better optimization, which means that, for example, for the AND, we know that it's always true if both hands are true, and we know that the left hand side is always evaluated first. For the AND, the left hand side is evaluated first, and if it's false, the right hand side will not be evaluated, because we already know that the result is guaranteed to be false for the AND. Same with the OR. We know that again in Java the left hand side is evaluated first, and then if for the OR operators the left hand side becomes true, then there is no need to basically evaluate the right hand side. The result will be true, right? That's called the short-circuiting behavior. So operator description, conditional AND, conditional OR. Again, these are not bitwise AND, bitwise OR. These are logical AND and logical OR, or as it's called here, conditional AND and conditional OR. The following program, conditional demo, tests these operators. We have two integer value. We test that value 1 is equal to 1. Remember, this is the equality operator, right? And then value 2 is equal to 2. And we said that for integer types, we can do exact equality test. That's fine, because integers, as long as there is no underflow or overflow, we have the exact full precision of the integer present. We said that this is not the case for floating point numbers like float or double. You should never use the equality operator to compare two floating point numbers. You have to do approximate tests, right? And we said that the wrapper classes like double and float provide a comparison. They have utility static methods, to compare two floats with some accuracy. So here this is condition 1 and condition 2, and we're using a and logical AND operators, and it does have a short-circuiting behavior, which means if the left hand side, which is always evaluated first, if it turns out to be false, the right hand side will never be evaluated, right? And the second one, we're using OR, and if the left hand side becomes true, then the right hand side will never be evaluated. Now let's create a new class and go ahead and test these. So conditional operators, and then let's have a main method. In the main method, I'm going to just create a new static method, public static void test1, and here we're going to use the test the short-circuiting behavior. So the way I'm going to do it, I'm going to create two methods. So public static void method1, and I'm going to return true, but then I'm going to also print out method 1 to say that this method was called. We're going to return a boolean instead of void boolean, all right? And we're going to do the same thing with method 2, and we're going to return false here, for example, all right? All right, so I'm going to say that boolean x1 is method 1 and method 2. So let's do a sysat on x1. Now, as I mentioned, for a binary operator, remember that AND is logical AND is a binary operator, and the left hand side will always be evaluated first. So let's run this. So method 1 was executed because it's on the left hand side, and method 2 was executed, it's on the right hand side, and then the result came out to be false. Now method 1 returns true. So when at runtime we evaluate method 1 and it's true, so we cannot still make a definite decision about the result, so we have to go and evaluate the right hand side, and it returns false, so the entire thing is false. Now if the second one, method 2, returns true, then we still evaluate both methods and the return is true, right? Because the left hand side is true, the right hand side is true, so both true. Now notice what happens if the left hand side becomes false. Here you see the right hand side was never evaluated because of the short circuiting behavior. So the short circuiting behavior means that for a logical AND, we know that if the left hand side is false, the result is guaranteed to be false. So there is no reason to evaluate the right hand side. But let's have a look at the bytecode to see if there is any difference when we have this short circuiting behavior. So in the test 1, so this is test 2, so we're looking at the conditional operators. So let's save this, and conditional operators, let's open it with a class file viewer, and let's have a look at the bytecode here. So method 2 and then test 1. So let's see what happens in test 1. Let's zoom in a little bit. All right, so invoke a static, we are invoking method 1. It's a static method, it doesn't take any parameter and returns a boolean. And then if equal means you compare the result to 0. If equal means compare to 0, right? You tell it if equal means whatever is on the stack at the last position on the stack, compare it to 0. If equal, jump to line 16, icons 0, and then put it in x1. So as you can see, the short circuiting behavior even happens on the bytecode level. So I'm going to write it down, or maybe before printing this out. So short circuiting behavior is in the bytecode, which means that it says that you're doing a logical AND. Note that there is no operation about logical AND here. It just says that get the left hand side and then compare with 0. If you recall, we said that boolean is in bytecode, boolean is just integer 0 or 1. So it gets the result of this after invoking this static method. The result is going to be on the stack, right, when it comes back from this method call. And then it says that compare the last value on the stack with 0 if equal. And if it's says that if it's equal to 0, if equals means basically it means if method 1 return value is equal to 0, jump to line 16, which means icons 0, load a 0 integer value, which means a boolean false. Boolean false, right? If you recall, we said that when we have a 0, when we have false, it means a 0 in bytecode. And then after that, it puts it in the x1. iStore means store an integer at the index 0, which is x1, right? So the result will be x1 without ever calling method 2. So this is the short circuiting behavior. And then otherwise, so if it's not equal, so otherwise, so you see that we have a jump method here. If equal, jump to line 16, so it skips 12 and 13. Otherwise, we continue with 12. We load iconst 1, which means boolean true, right? And then and after that we'll go to 17, right? So there is a go to method. We jump to 17, iStore 0 x1. again we store it in the x1, right? So again, it just looks at the left hand side, and this is what the Java compiler does. So short circuiting behavior is what Java C does, right? Java C realizes that you're using a logical and it has a short circuiting behavior as per the Java language specification. So it basically actually what happens here is that after method 1, if it's 0 we jump to 16. So we already, but if it's not 0, I forgot something. So if it's not 0, which means method 1 doesn't return false, it returns true. Actually we go and execute method 2. So we actually invoke method 2. So otherwise we go ahead and invoke this method 2 and then continue with the value that it returns. So method 2 here, we invoke this static method, and then we check whether if it's equal to 0 or not. So and then if method 2 is equal to 0, we jump to 16. Eventually the result will be 0. Otherwise basically we load 1 and the result is true. So the short circuiting happens at this jump right after executing the left hand side or evaluating the left hand side. And we say that if it's equal to 0, if the left hand side or result of this method 1 call is 0, just go ahead and immediately go to 16, which means load 0 in x1, which means load false. The result is false. There is nothing else to do. Don't look at the right hand side. All right. So this is the short circuiting behavior. Same with the OR. We can also look at the OR. So let's create another one. I'm going to call it test2. And then we're going to do a pipe operator, logical pipe. And then let's see what happens here. So let's go ahead and execute test2. And the result is true. Both methods were called because method 1 returns false. So when the left hand side is evaluated and it's false, we can't make a definite decision. So we have to go and evaluate the right hand side. Now note that what happens if I run if method 1 returns true. Note that what happens in the calls. As you can see, method 2 was never called here because the left hand side returned true, and therefore we know that the result of the expression will always be true, right? So let's look at the bytecode again for this method test2. All right. Now in the bytecode we go ahead and call method 1, and then if not equal. Now we know that we want to see if it's true because the left hand side it's important to see if it's true. True means if not equal 0. Basically what this says that if the result value of not method 1. So after we come back from this static method, the result of this method is the last index on the stack. And it says that if the last index on the stack is not equal to 0, which means we are the Boolean value, which means method 1 returned my keyboard changed. It means that method 1 returned true, right? And then if it says that if it's true, basically if not equal 0, which means the method 1 returned true, jump to 16. 16 means just load 1. So I const 1 and store it in the x1. So the result is true. Don't bother evaluating. So we load 1 in the stack, and then we push it to variable x1, which 1 means integer 1, integer constant 1 means it's a true value for a Boolean type, right? So we evaluate method 1. If it's not 0, which means if it's true, then we just immediately push through to the x1 and we don't bother with the x2. Method 2. Now this is good because it can offer optimization or a little bit speed up if, for example, method 2 takes a long time. But then the jump operations always, if you can avoid jump basically operations in your bytecode or in your source code, it's always best to avoid jumps. For example, if not equal, it's a jump operation. It says jump to line 16, for example, right? Usually it's better to not have various branches, but this branching happens at the bytecode level. When you write your source code, method 1 or method 2, right? When you write this expression, it's not explicit branching or if a statement. It's the way that the bytecode is written based on your source code, right? So this is very interesting behavior, short circuiting. Other programming languages like C++, C, Python, they also offer this short circuiting behavior. Another conditional operator is a ternary operator, a question mark, colon, and I believe we looked at this before. And this is exactly the same as if you write the if-else statement explicitly. This operator is also known as a ternary operator, and this is the only ternary operator. You put the condition before the question mark, and then between the question mark and the colon is the return value if the condition is true. After the colon, you put the return value if the expression is false. And this is the only ternary operator in Java because it uses 3 operands. In the following example, this operator should be read as if some condition is true, assign the value of value 1 to result, otherwise assign the value of value 2 to result. So the following program, so we are using a ternary operation here, some condition, so the condition gets evaluated first. If it returns true, the value 1, if you have an expression, then there it will be evaluated, and the result of the evaluation, the return value will be returned by the entire ternary operator. Otherwise, this right hand side expression will be evaluated and the return value will be returned as the result of the ternary operator. So let's go and have a look at this one. So let's have another method, public static void test3, and then I'm going to say boolean x1 is method 1. So if method 1 returns true, go ahead and say method 2, else method 1. Now the reason I'm doing this, I want to see whether so obviously we want to see the order of execution of these conditions, and obviously the condition should be executed first, and then the question is there a shortcut here, short circuiting here, which means that if the condition is true, this one is going to be evaluated, but whether the other expression method 1 is also going to be evaluated or not, which most likely is not. So let's see. So if I run this, as you can see, method 1 was evaluated for the condition, and then method 2 was evaluated, but then this the other condition is not going to be evaluated. So this exactly behaves like an if-else statement, right? And then the result came out to be false, right? Because it's true, this condition is true, this program prints 1 to the screen, right? The result value. Use the ternary operator instead of an if-else statement if it makes your code more readable, because it's just one line of code. The bytecode is going to be exactly the same as if you write the if-else statement yourself. For example, when expressions are compact and without side effects. Now, one of the things that I typically do, one of the use cases that I have for this expression is checking object references for null, for example. So for example, I can say a string null, a string s1 equals null, for example, and then I can say for example a string s2 is s1 equals null. If it's null, I'm going to say default value, else I'm going to assign it to s1. Now this is a little bit cleaner. We have a quick test for null. If it's null, we're going to do this, and then else we're going to assign it, right? And then let's print s2 here, and s2 becomes default value. If this is not, for example, hello, then we're going to jump to other branch and print it. So sometimes for strings, if you want to quickly check if it's null, and if it's null, you want to do a quick action. So this is more about quick checks and actions, right? Then you can do this kind of ternary operator. So I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.